Turning now to the first project, we've called that an environment project, and this is based on our CLEAR laboratory, and you probably find as the evening goes on, we love acronyms here. That actually stands for, you probably can't see it, it's on the bottom of the slide, Characterisation Laboratories for Environmental Engineering Research. And through the facilities and expertise that resides in that laboratory and amongst the academic staff, we're going to focus on organic and inorganic liquids, gases and solids. And the kind of things we can do are listed there. We can evaluate the environmental impact of solid waste, be it leachates from waste, from mines, from industrial waste. We can evaluate the acceptability of waste for whatever disposal process is going to be considered. Also, for remediation, for improving wastes and developing them for other applications, we're able to set up bespoke environmental process engineering solutions. These are scale size facilities where we can actually evaluate the effectiveness of the process with liquids and solids and so on. Also, we're able to characterise a vast range of organic and inorganic materials, be they solids, liquids, gases, compounds, and so on, which can enable then a decision to be made on what treatment would be provided. Well, which Welsh industries might be interested? Well, there's quite a list, as you can see there, ranging from mining through water treatment, recycling, and process engineering. So a very broad connection to a large group of industries that are highly active within Wales and highly pertinent given today's environmental agenda. Turning to the second project now, that's called Performance Engineering. That's based on the expertise of our CUSP laboratory, which means, in effect, our Structural Performance Laboratory. We'll be focusing on 4 cutting-edge technologies there, which I'll take you through. The first is rigid body dynamic analysis, where we're able to do complex complex computer modelling of complex systems. This could be things like a vehicle suspension or a robot. We're able to actually model exactly what happens with those systems to useful effect. Next one is acoustic emissions, which is a non-destructive technique that can allow crack growth and damage location during loading to be detected in an enormous number of different materials, ranging from concrete through wood to steel. Digital image correlation is an optical technique which allows displacement and hence strain under loading to be actually visualized while the component or structure is actually being loaded. And then finally, we have a large autoclave in the school, and we're going to make that available to companies who wish to manufacture large-scale, high-quality composites. You may have heard that composites are becoming increasingly important in many industries, most notably aerospace, through their high strength-to-weight ratio. Again, which industries might be interested? Well, quite a list again: automotive, through defence, civil, structural, medical, and general manufacturing. Any company that in fact is making a product for which the expertise and facilities we will offer might be applicable. Final project is quite new and quite exciting for us, called Green Communications. This is based upon the research we've done here in our high frequency laboratory, and is focusing on the emerging, and it is emerging, market of green communications. And this is all to do with helping companies to make to develop electronic components, produce electronic circuitry and systems that actually consume less electricity. So in effect, there's less CO2 produced in producing electricity to drive them. This is, say, a new sector, and we have an opportunity here to create a new, vibrant opportunity in Wales, not both for current companies and also to attract international players. Through our work, as is typical of these projects, the aim is to help these companies that exist and new companies to make their products more efficient and hence more attractive in the marketplace, and, as I say, consume less electricity, hence less CO2 is generated. Again, quite a list of companies through aerospace communications, through suppliers of power electronics and components, network control and management companies, manufacturers of measurement instrumentation, and interest in developers of CAD software for electronic design. Now, just a brief case study, and this relates to digital image correlation, which was part of our performance engineering project. The client here wished to confirm that the finite element analysis they'd carried out on a part subject to cyclical loading was actually correct, and showed that in a critical corner position, which is here, the actual strain was in fact compressive. This was very important because the company was trying to cost reduce this part and needed to know where it could take metal away without affecting the structural integrity of the product. We used DIC to demonstrate how that could help, and it's really interesting because you simply spray the surface awfully badly, as you can see, with black car paint, and then using the camera system that's involved and the software, it's possible to actually get a picture of the strain that's actually present in real time while the component is actually being loaded. And may not be able to see from the scale at the side, but it did show that the strain here is actually compressive, and also showed, interestingly, that it transitions to tensile fairly near to this corner condition. And this was invaluable information for the company, and I think it shows you that virtually any component could be treated with a paint, analysed this way in full 3D. So this is a very powerful technology. Other business services we can offer beyond those funded by A4B, well, of course, importantly, consultancy and problem solving. Beyond the projects I've described, we have a vaster range of expertise and facilities which we are always available to industry. Also research, I mean, that can be where a company sponsors the research fully, although there are opportunities to leverage in other funding so the company doesn't in fact pay the full cost. Good example is industrial case PhD studentships. We have a number of these awarded every year, which can substantially reduce the contribution from the sponsoring company. Also, we're very active right now in providing help with CPD, continuing professional development, and training in general. Using our taught modules, both for undergrad and for postgrad, we're able to put together some highly bespoke courses that match the precise needs of the client and actually can then deliver them. We also have an excellent range of MSc courses, more on them later next door, which have been developed really to meet the needs of it that industry faces today. So in summary, we're here to help. I'm the person to contact. If you'd like more information, I'll be next door later with some of my academic colleagues, so please come and have a chat. Perhaps you've got a project for us already. But meanwhile, thank you all very much for listening.